Hi, my name is Daniel. My group and I will be talking about the San Francisco-Oakland Bay Bridge, which was recently completed in September of the past year. The original bridge was built in 1936, and like many other structures, it was faced with many obstacles, mostly political. But once it overcame these obstacles, once it was built, it was the longest steel structure of its kind in the world at that time, and it quickly became the favorite method of transportation across the East Bay. Unfortunately, in the original design, the engineers forgot to account for the earthquake danger that was imminent in the area. When the Loma Prieta earthquake struck in 1989 with a magnitude of 7.1, disaster happened. Part of the bridge collapsed, trapping many people in their vehicles and killing others. So when the planning started for the new Bay Bridge, the main focus was to have a bridge that was capable of withstanding earthquakes of similar kind. This was mainly done by changing a couple methods. One of them being the hinge pipe beam, which allows for contraction and expansion, which will be talked about later.
My name is Mayra Velasquez, and I will be talking about the past practice of the Bay Bridge. It was said it was impossible to construct the bridge because the water separating the cities was too deep and wide, and due to potential impact of the turbulent waters in the high winds. An anchorage will be constructed with a concrete pier that supported the end of each of the two suspension bridges that connected from Yerba Buena Island to San Francisco. 55 steel tubes in 15 diameter were compressed with air for the construction of the center anchorage. Air pressure was maintained in the cylinder to control the sinking as concrete was poured into the spaces between them. On reaching bedrocks, the mud was scooped from the cylinder and replaced by a 34 feet concrete seal. Steel cutting edges were built with hollow steel cylinders, and the wooden walls were encased by a cylinder, and the new units were added on the top of the case sinking process. With catwalks on the position, the cable span and galvanized wire was used to bind together Oakland and San Francisco. The cable consisted of 37 strands, each made of 472 galvanized steel wires as thick as a lead pencil. A shuttle wheel took a loop of wire from one anchorage and carried it over the lower to the other side of the anchorage, then connecting them to an anchor eye bars. The process continued until the wires were cut and spliced to the beginning and end. Then the end coil of the wire is joined to the beginning of the next part of the coil by means of a turnbuckle pipe splice. Each wire is wobbled so that when they are ground together by a turbulent sleeve, the ends will fit snugly. Mobile ends form a lock and would not become loose unless they are unscrewed by a wrench.
Hi, my name is Eduardo Castillo, and I will be talking about the modern day methods that were implemented onto the new Bay Bridge. When we're modeling the new Bay Bridge, they retrofitted the west span and completely remade the east span. Two of the major changes that we can see on the new Bay Bridge were the implementation of the hinge pipe beam. The hinge pipe beam works by the tube moving within its sleeve. This allows for the new Bay Bridge to expand and contract in temperature changes, but also able to move a substantial amount if an earthquake ever strikes. The old Bay Bridge did have expansion gaps, but it was only able to move a couple inches. And in the event of an earthquake, the expansion gap would slam. This new hinge pipe beam allows for the movement of up to 3 feet within the bridge. Another implementation that happened with the new Bay Bridge are the shear link beams. The west self-anchored suspension section of the east span is composed of a main tower. The main tower has 4 individual steel legs that are each connected through several shielding beams. These shielding beams allow for the complete and independent movement of the steel legs. If high winds are to strike, or if an earthquake was to strike, the shielding beams would move side to side and up and down, allowing the tower to move freely. The 2 main ideologies that were followed throughout the remodeling of the New Bay Bridge were being able to replace small parts and allowing the bridge to move with the motion of the seismic activity instead of taking it all at once. Both the hinge pipe beam and the shielding beams are able to be replaced and removed at any time if needed.
We chose this project because we are interested in the structural part of civil engineering. We also chose it because it is always good to educate yourself on some of the amazing feats that happen in this engineering world, like the ones that were achieved in building these 2 bridges. Future designs will most likely start going towards the green side, just like we are seeing now. Only the future will tell what techniques and designs are used in future bridges. Thank you.